everyone. Nice to see you all here. Thank you for joining our panel. Our panel called Power Innovation, How is the Industry Adapting to the Density Challenge? And you know, the power used to be a utility once. Now it's a strategy. And the companies that figured out energy first will define the next decade. Not the ones with the best technology, but the most capital. So I want to discuss today what's happening. So what is important? Is power, where power is available, where projects are slowing down, what technologies are realistic, and whether Europe is moving fast enough compared to the US or China. And I'm happy to have my experts today to discuss this topic. So my name is Anna Klaft. I'm the former president of the German Data Center Association, and now have my own companies called KLF, and for the strategic advisory, and another company, DCS, who is doing technical advisory for companies who are joining the data center market. So and I'm happy to have, I just learned today I have a new employee because Bruno is here. Bruno is from NTT, actually. But you know, he joined me today. This is really great. So I feel really fine now about that. So then we have Tim Hall, who is a member of the executive board and labor director at Siemens Energy. Welcome. And Michelle Fraze, a European vice president and CTO from Huawei Digital Power, and Krupal Rawal, who is chief strategy officer for CyrusOne. So welcome to my panel. Thank you. And I would say we start now with some basics, just to learn about the power. And Bruno, first question goes to you. As you're working now for KLF, you have a lot of insights. So is power now the #1 reason projects are failing or get delayed?
So thanks, Anna. And I do not work for KLF. I have to still see the job description. I'm with NTT Global Data Centers, and we're a design build operator of co-location facilities, and we provide services to hyperscalers, enterprise companies, and companies deploying AI. So we've been doing this globally for a number of years. And to answer your specific question with regards to is power the #1 reason why projects are getting delayed and or canceled, I think from the perspective of NTT, power is definitely a main consideration and something that is delaying our projects. We've had projects delayed because of power availability, and we've actually had projects that have changed delivery dates because of inconsistencies in some of the information that the grid providers are telling us, and things changing during the construction process. So power is definitely something that we're monitoring and have to manage more proactively than we've ever done. I think it's an interesting thing. If you look at the industry, I think we're at a pivotal point as a data center provider in that we used to just be a customer or a client of grid operators, but now the thing that's happening is we're partnering with a lot of utility providers to actually contribute and build and update the grid. That's kind of one of the big fundamental changes that have happened. And if you look at all data center companies currently, we all have power teams now. We used to have a few people that maybe worked with the utility providers on ESAs or different agreements to secure the power. Now we've got a full team that's not only working with the utility providers, but also working with different options, because we can't be stuck with only one way of getting power to the data center. So it's really changed the way we look at it. So power is a big consideration, but it's part of the process now. I'd say we're less victims of it and more drivers of at least trying to make sure there's a solution to power the solution or the data centers and the projects that we're enabling for our clients.
I would go directly to you, Krupal, because you're also making decisions on locations every day. How important is power?
Yeah, so similar to Bruno, we do have a power team, and CyrusOne, very similar to NTT. We, well-established company, 25 years in this business, built a multi-gigawatt portfolio of operating assets. What's changed a lot is power has become like the #1 consideration for how we think about our investments. So the way we're phrasing it is a power-first strategy. because fundamentally, when we think about our site selection, our investment program is entirely built on where the power is. So it used to be that you choose particular locations because of fiber and the connectivity equation, and connectivity is still an important variable, but you can build fiber to various campuses that have power, but it doesn't work in inverse. So to bring the power to places that are connectivity hubs, that's incredibly hard now. So it used to be X number of years ago, the site selection criterion was that you were saying like, look, I want to be in X metro, and the aperture that we're looking at, the rings that we're looking at, and not just us, but everyone in our peer group, has the scope is widened. So as we look at our new markets that we're looking at, Dallas is still a very important market, but it used to be you want it to be within a certain distance of Infomart, as an example. Now the definition of what Dallas looks like is within 100 miles of Dallas per se, right? So it's a continuation of the prior theme, but it is truly a power first strategy that we're focused on.
Yeah, so Tim, maybe for you, so you are connecting the energy world to the data center world, right? So how far behind is the grid?
So I was just listening carefully. We always talk about power, and I think we should need to differentiate between generation and connection, right? There might be enough generation there, but if you don't get the connection, then you cannot run the data center. But coming to that, if you look at it, the demand is there, the money is there, the infrastructure is there, and it's almost logical. If you see a data center gets now built in a year and a half, 3 years, if you're really fast. If you look at planning cycles for the grid, in Europe, 7 to 10 years. Rest of the world, 5 to 15 years, depending where you are. So the gap is at least 2 years up to a decade, and that's what we need to solve. On top of it, you have the lead times on equipment, where historically 5 years ago we could deliver a transformer in 12 months, 18 months. We're now up to 5 to 6 years on the large power transformers, and also that creates that bottleneck. So the grid is important. I think we're working on making sure we really understand what's needed. As an equipment supplier that's used to work with utilities that have kind of 6-year planning cycles, we're learning also a lot on speed and what it takes. But the grid will, in my opinion, remain a major bottleneck in terms of getting the connections and getting all your data centers up and running.
So you're saying, yeah, okay, we need to solve one problem, the power, and Michelle, we need also to solve the AI demand, right? So what do you think about what will differentiate successful AI infrastructure in the next 5 years?
I think that you need, there is different topics. You need to focus a bit on the product and solutions regarding the infrastructure to power the AI data centers. And I think you need to have high efficiency, power distributions, cooling distributions. And I heard before that we need to have a mix of both, the fan-cooled and of course liquid-cooled to chip. This is quite important to lower PUE, but also to lower the power consumptions. The other things we need to do, I believe, is to have more integrations between the data center itself and the energy parts. And one example I could give is consider maybe to use the battery energy storage system to reinforce the grid. So that you can use what is available for the grid, and the extra power that you need during the day, you can use it from the battery energy storage system that you can recharge either using solar plants if you got enough rooms, or using the energy during the night where the power consumption is less. So this is one thing you can do. And then finally, AI data centers, to run them properly and to improve the efficiency of the operations, I think you need to use AI software as well. And this AI software can help you to have some predictive maintenance, to know when the problems will arrive before you arrive, so you don't have to rush and go on site. But it can help you also to optimize the electricity consumptions. As an example, we can have some AI cooling systems to reduce the cooling consumptions by just optimizing the different parameters, but in an automatic way.
Yeah, but energy challenge is not just technical. So my question would be to you, Tim. Europe is talking a lot about sustainability and energy transition and all of that. What do you think? Are current permitting and grid expansions timelines compatible with the industry actual needs? So this is the question.
Yeah, I was alluding to it. I think the speed we have seen on the data centers collides with what we have seen in terms of the speed of the energy transition. And if you look at typical grid connection project, even if it takes 7 years, it takes like 2 to 3 years to build and more than 3 years to plan and getting the permitting. So for us, it's really essential, how do we really accelerate on the permitting? How do we get the speed on connecting? If you look at different countries, the queue that you have and how much is not connected in terms of data centers. Germany, 600 gigawatts of potential data centers that are in the queue. US, we see the same, starting to build up. That will be the real bottleneck. And the question is, how do we standardize? How do we have a system-wide approach to really resolve that bottleneck? For us as a manufacturer, transparency helps. I'm ramping capacity up. We invested last year alone over $2 billion in capacity expansions, but that's not enough. So it's planning, expansion, system view needs to go together in order to really solve that dilemma of how do we get faster connected.
So Krupal, you just mentioned the US as well. So what do you think is the biggest advantage for US and China compared to Europe?
Yeah, it's a great question. I think, so US is unequivocally, one of the energy richest countries on the planet, one of the biggest producers of oil, one of the producers of natural gas. And so if you look at global energy input prices, prices are actually down in the United States as an energy input, whereas like in Europe, the prices for natural gas, when it's liquid natural gas, or coming from China, from Russia, or wherever that gas is coming from, that gas is much more expensive here in Europe. And so the advantage that U.S. has is being energy rich, and frankly, a lot of the customers, if you look at the numbers, 50% of global data center build is happening in the United States, and it's a virtue of obviously the energy element that we just discussed, but it's also the customer base, because the lion's share of the growth is coming from these major U.S. hyperscalers and the major U.S. LLMs as well. So that kind of dimension is unequivocally advantageous for the United States. What China has, China is one of the most fascinating markets in my opinion, in the sense that China has some of the most sophisticated AI researchers, right? When you think about the raw talent, there's enormous talent, and the fact that you have a government framework that allows the rapid deployment of building, which is an advantage versus here in America, or not here, but in America, the time scales to develop are taking much longer, which is kind of one of the friction points. And so China's in a unique position, but when you think about the innovation that comes from the likes of Microsoft and Anthropic and NVIDIA, like all of these companies are US based, and so it's kind of like they have these advantages, but a lot of that raw talent, that advantages that they have, it's not serving the same customer base, which is where it's like this ping pong. But you're kind of having a bipolar world in the sense that US and China are the runaway leaders in AI. And then Europe is, it's a very relevant market, but in AI, it's not keeping up with the United States or China.
And Bruno, maybe to you, you know that Europe has a lot of regulation as well. Do you think that it's helpful? For some reason, I don't know, maybe to be more competitive, I don't know.
Is it being recorded? So regulation, I think, is actually hurting some of the European expansions for us. There's certain regulations that have been enacted that actually weren't really enacted with the right metrics. And I'll be specific, like in Germany, they're really focused on PUE. and trying to make sure that PUEs were a certain level and so much renewable energy was being put in. And I think that's actually slowed down the industry because some of those requirements and metrics were not achievable and actually counterdicted some of the sustainability goals that we were all working towards. So I think regulation hasn't necessarily helped the ability to expand in Europe, but the demand in Europe is there. Like, we're seeing a lot of customers want to expand. There's demand from sovereign. AI inference is really starting to pick up. Our customers are really wanting to expand and do that. So the demand is there. We got to figure out how to balance the right amount of regulation. There's some things that are positive with the heat reuse and the way that the data centers can actually contribute to the community. I think that's critical, and regulating that is great. But some of the other things, I think we need to do a better job of partnering and working with the communities and the governments to come up with responsible regulation as opposed to irresponsible regulation. And the interesting thing with Europe that I'm sure some others can comment on as well is that every country is a little bit different. And there's countries that are very pro data centers that are really enabling it, taking advantage of it. We heard some of the examples today with the investment that's happening in France, Italy, Spain, and the Nordics. But then you look at some of the other countries like Ireland and the UK and Germany that's actually slowing down the data center development. So it really varies by country, but we're trying to work very closely to make sure that we're doing the right thing and working with the governments on the right regulations.
Michelle, what do you think about that? So do you see an advantage in Europe compared to China?
I see. If you look at the latest report for the European data center industry in Europe, basically the appetite for data centers in Europe is big. The capital is here. What is missing is the grid and the power. And instead of tripling the investment, we're probably going to doubling the investment. So I fully agree with Bruno, and what has been said is, I think it's not regulation, I would say, it's more the administrative. All the administration is taking way too much time compared to China, compared to the US or to the Middle East or other countries. And this is what is hurting Europe in terms of its capabilities to become, if you want to become, and have a sovereign cloud, we need to move faster, we need to simplify. This is my view.
And Tim, just from your perspective, which region has the strongest structural advantage?
I think each region has a bit of a different advantage, I would put it this way. I mean, US, very execution focused from discussions until we get going. It's much focused on speed. China, we see the same thing, big data, standardize, how do I get it done? I think in Europe, the technology discussion comes into play. I think you probably get the more technology advanced solutions and the more reliable ones. But of course, it comes at the disadvantage of losing speed and going back and doing these hundreds and hundreds of pages of specs in order to come to it. So I think each region has a bit of a different challenge, all good challenges, and I think at the end we see also key learnings that the utilities take from different regions and adapting. So I still have this vision that at 1.5 years down the road, we're a lot narrower in terms of what it takes to get data centers online quickly.
Staying for a second with you again. So there is a quote from you saying AI is not only driving demand growth, it is also part of the solution. What do you mean by that?
Yeah, where we spend a lot of time is looking how efficient is the grid. I mean, one is, of course, the AI-driven data center boom. The other one is how can we use actually AI to optimize the grid? And if you see how a grid normally gets designed and operated, it has a lot of safety margin. It's probably, we see a lot of curtailment in the grid. So back to the previous point, there is not enough power. There might be enough power, but it's not in the right places. So what we're now focusing on, how do we use actually artificial intelligence to operate our equipment harder? And I always compare it to, it's like a highway. There's so many cars go through it, and then you start to seeing a congestion. If you have an intelligent traffic flow management system, if you have an intelligent system to operate the grid, you can actually overload in certain times the substation, the equipment, to make sure you really have the power where it's needed, or you don't need to curtail power that's in the grid that both of you need for your data centers. So that's where we're putting a lot of effort in terms of sensors, digital twins, working together with NVIDIA, having the grid flow optimized to make sure enough electrons come to where they need it, and we don't need to stop generation because the grid cannot just digest it.
Well, Michel, you just said missing grid and power. What is currently the biggest challenge, and how would you solve it? Do you have any idea how we get more power in Europe?
You can come to France.
To your nuclears, you mean?
Yeah, nuclear is a good way, and I know there is thinking, especially in the US, regarding the SMR. This is one thing. In the short term, this is very long term. So in the short term, as I previously mentioned, I think BESS is probably battery energy storage system is probably one good way to help the grid basically, and it's also one way to generate new revenue by being an active component of the grid, because then you can do some great balancings to both in terms of capacity or frequency. Because if you don't do that, I mean, AI data centers, the load is moving all the time, so it's very difficult to balance the productions and the consumptions of the grid. And if you don't do that, it will happen what happened last year about the same time in Spain. It will be a complete blackout. So this is one way of doing things. What we are seeing as well is, we're seeing new technology. We mentioned 800 volt DC, so higher voltage is certainly a way to go to lower the power consumptions, and make it more efficient. We see the future architecture changing. So what we say is, the power trend may become like an energy router. So you can have multiple input, multiple output, multiple input with different AC power. It can come from the grid, it can come from microgrids, it can come from the batteries, maybe others tomorrow. And regarding the output, you must be able to be flexible, because you're going to have equipment which will be 380 volt AC or 800 volt DC. So you need to basically have an infrastructure which will be adapted to the different load, and not force the load to be only 800 volt DC or only 380 volt AC.
And what do you think about on-site generation?
On-site generations, we promote solar for sure. And if not, I know in the US where you got some gas, maybe the permitting is faster. Maybe you can put your own, energy generator on site. This is something you can do. Why not? But as I mentioned before, by my colleagues here, it's also, the data centers before it was connections. Point now is where is the power? So we should move where is the power, because this is very important. Generations, but there's also distribution, which is important. Huh? And I think this is one of the challenges we're facing.
Yeah.
Yeah, I was actually going to add to that. Actually, I found a separate mic, so that works. So what's unique about what we've done at CyrusOne is that we've already established partnerships with Calpine, for example, where we're doing on-site power generation. And I think that this is kind of a trend that this industry is going to be hopefully gravitating towards, because fundamentally, to the point that Tim made about seeing how do we optimize existing infrastructure, that's one significant element. But no matter what, when we think about it, between advanced manufacturing with electrification of cars and data centers, these three variables are driving a lot of incremental net new needs for electricity. So as an industry, we need to make sure that we're not straining the grid, but we're adding to the grid. We're adding to the net. We're adding to the solution. And I think that as an industry, we probably haven't done as good a job as we can and should talking about all the advantages that we're bringing to the community by saying we're bringing net new generation and hardening the grid, making investments in distribution and transmission infrastructure that benefits everyone. So there's a lot of anti-data center rhetoric out there, which is maybe somewhat understandable, but I think we need, as an industry, need to do a much better job at articulating how much we're adding to the net solution. And Calpine is the first that we can talk to. Here in Europe, we have E.ON. In Japan, we have a partnership with KEPCO, which is the grid in the Kansai region. And so, this is a consistent theme that we've been working towards. And, I think as an industry, we all should be doing more of that, I think.
But you're just using this on-site generation while you're waiting to get more power, or are you using it constantly?
Well, so the theme that we have is that it's on-site generation for a bit of time, but it can be permanent as well, because that energy infrastructure, those assets that are generating new electrons, those assets are not there. It's not like a wheeled-in, plug-and-play type of thing, similar to what I guess it was XAI had for Memphis, right? That was temporary generation. This is permanent generation. So it can take both flavors. But what we're doing is we're building long-term new generation into the total country grid.
If I can just comment on that, because I think this is part of the interesting thing that's happening in the data center industry right now with regards to, we had a problem, this power problem isn't new, right? We started talking about this 2-3 years ago, maybe even longer, and now we've come to provide different options and solutions behind the meter, on-site generation, battery storage. We've innovated as an industry to provide options, and I think that's been a really important aspect for us to keep the projects going and provide value to the customers and obviously provide value to the community. I think that's something we've done. And the point about the on-site generation, it's not a bridge or temporary or permanent. I think it's actually time for us to even rethink how we provide our general services. For the longest time, data centers built the same thing. We got grid power, we had generators as a backup, we had UPSs, batteries, and N+1, 2N, different types of architectural resiliency solutions. If we start doing, we have, but when we do it more often where we've got behind the meter, we've got on-site generation, it's time for us to rethink that resiliency. Should we use that on-site generation as a backup instead of generators which burn diesel fuel? I think it really gives us an option to be more innovative and actually a better steward. And that's what's fun to be in the data center industry right now. The change that we've been doing in the last 2 to 3 years and the innovation that we've introduced has been significant compared to the 20 years before that.
You can go ahead.
Maybe a bit of a different view. I mean, if you go back 150 years, how did the grid start in the US? It was all individual towns who had, small grids, and then over time, it got connected because that's where you get the efficiencies. You have central generation, you have different sources of generation, and now I think it's, I would assume the majority of data center operators wouldn't do their own power if there wasn't such a shortage of the power. So it's a necessity because the grid, the utilities cannot get it fast enough online. The question is, now we're building the second infrastructure, a second grid that we see in the US. Does it get grid connected at one point and you're going back? I think there's different options. Knowing that we built the equipment and operate it, the most efficiency you get on large units. You have a large combined cycle. What happens if that goes, on an outage, which can be 4 to 6 weeks? Do you then need like a gigawatt of power from the grid all of a sudden and you have to switch it on? So you have to think through the implications. I think as a bridge to get to where we need in terms of having enough power, having enough grid connections, I think it's a right step. We just need to think, what's the next logical step after it and how do we all bring it together? Because at the end, we're going to talk about cost, efficiency, reliability, and that will have a major play as well.
Krupal, you just mentioned that you have already partnerships like E.ON and so on. How important are those partnerships?
I think they're critical because, to Bruno's point, yeah, we have a power team. NTT has a power team. Like a lot of the firms in the data center operating universe, have these teams, but we can't replicate, Tim, what you've built or what the firm has built. So fundamentally, working with partners, it's really the way that we've at least identified as a way to be able to create the scale we need, because it's sometimes worthwhile to think about the scale that we're trying to address, right? If you think about, pick your number. I don't know if there's any like consensus view as to how much needs to be built, but the numbers that get quoted are 150 gigawatts of incremental kind of capacity, data center capacity needs to be built. When you're talking about that alone is we're talking about, long term is going to be $1 trillion of data center investment, let alone what needs to be invested for the energy infrastructure, which is a critical component of it as well. So you need, just the scale of building the data centers alone is fairly meaningful. So for us to work with partners is the most logical way for us to think about how to grow.
And I would like to ask you all, what do you all think about power purchase agreements? Are they only used in Germany? I don't know, are they used everywhere? Because it feels like in Germany we have it all the time. We need to have them.
Yeah, I mean, I'll speak for the US and for Japan, but so yes, we sign up with these power purchase agreements, but fundamentally our core businesses are the vast majority of our customer base is the hyperscalers, and so it's a simple pass through. So fundamentally, whether we sign the PPA or end customer signs the PPA, we're agnostic on it. But fundamentally, I think what the root of your question really is in order to be able to invest the capital needed to build net new generation, these are massive capital investments, and so you need to have, in the same way that a data center operator needs a 15-year term from a customer to make the capital investment worthwhile. Similarly, on the power side, it's a meaningful amount of capital that needs to be invested. And so in order to be able to create that capital incentive cycle, that's why you need large PPAs to say okay, well, at least we know that this capital investment is going to earn a return.
Yeah, PPAs are critical, and I think that's a good way of hedging for power. But I think that the challenge is the rules are changing, right? So the PPA that we buy in Germany can't be used for power in France. And so the complications of PPAs are getting difficult to manage, but they're absolutely critical to provide commitments and investments into generation.
I think PPA is also one way to reduce the administrative work, because all the IPPs, they secure lands and interconnection points. So this is a good part of it. The second part, if you look at PPAs in Europe, mostly with solar and wind. And if you look at solar, I mean, it's one way to sign a 15 to 20-year contract with very low price electricity without any, surprise regarding what can happen in the market. And if you look at the leverage cost of electricity in terms of solar today, it's about 2 euro cents per kilowatt hours. And if you add some batteries, you go to 6 euro cents per kilowatt hours, which is cheaper than gas, coal, and nuclear. So this is one good way. Is that enough? Probably not, because you will need a lot of solar panels.
For me, it's just another instrument to make sure we really understand the demand and it gets built. I mean, a PPA, as you can imagine, we got quite a lot of inquiries. Do you have gas turbines? Can you build something? A PPA or an advanced negotiation on a PPA is a signal this is a real project versus somebody came up with it and it's a good idea to build power at the data center and connect it. So I think it's also a signal who are the real players in the market versus who are the ones who are kind of a bit more investing and trying to get a good return quickly.
Yeah, just to summarize and give you just a final question to answer. What do you think are the fastest and most critical measures to solve our power availability problem and challenge? Think about AI, so on a long term and a short term priority. Start with you can start. You start.
So I think we talked about some of them. I think it's more partnerships. I think the key thing that has to happen is we just got to work. They're not problems to solve in isolation, right? We can't just have the utility providers solve the power problem. We got to basically work better as an industry. And I think the interesting thing is before power companies built power, data center companies built data centers, end users use those data centers and put manufacturing equipment inside of them. The interesting thing that's happening now is that partnership piece. And I think at short term and long term, we got to partner with the grid operators, with the generators, the different ways of offsetting and providing a better electrical solution. But the interesting thing is we're partnering on the manufacturing side, where all of us are talking to NVIDIA about their next generation chips so that the data center designs can meet them. So it's partnering on both sides and almost creating an infrastructure ecosystem as opposed to independent islands of trying to solve these things.
For me, short term, it's really all about standardization. If you go out into one of our factories, large power transformers, output is about 70 to 100 transformers. They all look different. I can do a lot more if I build the same I can do a lot more if we would have a reference architect structure, say there's 100, 300 gigawatt data center, this is how we connect it, same equipment, same layout. So we need to kind of industrialize the grid connection. Long term, I think we talked about it, permitting. I mean, it's not the build time and the manufacturing time, it's the time to get everything permitted on the grid side, and then better planning. I mean, I think we're getting there, but knowing the demand, you know, these mega clusters of data centers, it just helps to also see how much do we need to invest in what area and get it done fast.
I think the short-term solution, the fastest one to help the grid and support the grid is, again, the BASS, because this is available and this is grid forming and easy to connect, so this is very short-term solutions. In the long-term solutions, if I have to mention one, which is not linked to our business, to the energy business, but more linked to the users, to compute, I think this is the reduction of power consumptions of the AI chips. And I think there is room there. There is a lot of rooms. And if I take a comparison, when 5G was launched, we said 5G will use a lot of power, which was true, more power because more traffic. But it was less power compared to the same amount of traffic. And every telecom players have been reducing their power consumption. I think this will happen as well with the AI chips, being with NVIDIA or Chinese or other players in this one.
I'm not sure if I have much to add, except for I think that the longer term answer is that obviously we need to invest a tremendous amount in net new generation, and that's a big thing. But I think that we also need to rethink what we're building, in the sense that there's a lot of capacity we build, especially in the United States, which is for a single day in the summer. So we're obviously preparing for like the absolute worst case event, and that's up until now it's been a practical way to approach how we build our infrastructure. But as we go forward, a lot of that capacity is underutilized for the vast majority of the year. And so I think that spending some time to think about how do we kind of prioritize what the maximum use would be. That's one thing. And the second thing is, from a data center perspective, on those peak days in the summer when everyone's running their air conditioning, maybe we need to throttle down the data center use and pivot those workloads to other areas that are not being kind of straining that local grid. So think about the topology of how people are putting those workloads to work. Those are kind of ways that you're making better use of these trillion-dollar investments, because fundamentally it is not logical for us to continue to build the way we've historically built.
We have 2 questions. I will just read them. I think you can all read them. How important do you believe grid connections and stability are to mega projects, multi-100 megawatt? And do you see those projects relying only on behind-the-meter options, or is it just not a possibility? Anonymous question. Who can answer that?
Maybe I can take a stab at it. So I think that having a permanently islanded behind-the-meter solution, I don't know if our customer base, if the market is ready for that yet. So I think the long-term interconnection story is a necessary component. But at the same time, like 2 years ago, virtually none of the customers were comfortable with behind the meter, and then 2 years later, that's just the reality we live in. So I think this is going to evolve, and so the thesis of having permanently islanded solutions, that will become more of a norm, but it's not yet.
Maybe to pick up on the grid stability, because we haven't talked about it. What we're now seeing is, especially on this data centers that are approaching a gigawatt, nobody is really sure, running the new AI models, what is the load changes? And I mean, we've heard, multiple 100 megawatts a minute. And the question is, how fast do you react? One solution is to include batteries as, but then there's another theory, the reaction time is not good. You need actually a STATCOM with supercapacitors under 1 millisecond to basically make sure you compensate the grid fluctuation. So I think that's an emerging field. And the question is, it all adds cost once you go behind the meter. It's not just a generation and a connection, then you also need the grid stabilization. So the question is really, I think, if it serves the need to get a quick on-power connection, yes. But what is kind of the end goal? Is it then giving it back to the utility and have it integrated, operated independently for the next 20 years? I think those models and those kind of approaches are still evolving, and I'm not sure we're completely sorted out what works and what doesn't.
Okay, and going to the last question we have. Thank you very much for your questions. Looking beyond AI, how are you thinking about quantum computing as a future demand driver, and what implications could it have for data center infrastructure, cooling security, and site selection? Who wants to pick up on this?
So I'll start. Just the quantum computing challenge or opportunity is actually interesting. I say we're keeping an eye on it and talking to some of our clients that are actually developing quantum computing chips and kind of starting to actually deploy them, which is really interesting. I don't think we fully understand what that means for a data center yet, other than we've got to figure out how to provide supercooling to those chips. But it is going to be an interesting technology leap. I don't think it's going to replace anything. I think there's just going to augment and actually provide different options, and we're going to have to figure out how to work with all of them. But it is an interesting jump in technology that I think we all have to keep an eye on.
So I hope the questions are answered, and I think we are in the end of this session. So thank you very much for joining us. I hope we've answered all your questions, and if not, then just ask us, reach out to us directly afterwards. Thank you very much.